Hello, innovators, changemakers, and entrepreneurs. This is Kevin Kimley. This is a show about the people, past, present, and future, who change the world. They make decisions and take actions enlivened by what I call the entrepreneur's ethic. The entrepreneur's ethic infuses people, organization, and places where the future is created and the world is made a better place. One of the entrepreneurs featured in my upcoming book, The Entrepreneur's Ethic, is early 19th century Boston entrepreneur Francis Cabot Lowell. Lowell launched a business, Boston Manufacturing Company, that pioneered integrated cotton textile manufacturing. Its importance was not just in the emerging textiles industry, but in providing a template for the audacious launch of many large businesses and industries in the coming centuries. There are 7 pillars to the entrepreneur's ethic. Lowell's work exemplifies Ethic 1, make things happen. This is the action orientation of entrepreneurship. In this episode, I explore today's textile industry with Luke Haverhals, CEO and founder of Natural Fiber Welding, a business that develops bio-neutral, high-performance textile materials from renewable natural nutrient inputs. We discuss the origin story of the business, synthetic versus natural materials, the environmental impact of plastics, and the pathway from startup to now working with BMW, Ralph Lauren, Allbirds, Patagonia, and many other highly recognizable brands. Luke and I discussed the idea of solving hard problems. I had to smile at that part of the discussion. You see, Ethic 2 is solve hard problems. We'll have much more on that in later episodes. I enjoyed this conversation with Luke and know that you will too. Luke Haverhals, PhD, is CEO and founder of Natural Fiber Welding. Luke's professional mission is to collaborate with and empower material scientists, manufacturing workers and engineers, investors, changemakers, creators, and brands around the world to create a truly circular and sustainable material economy from the ground up. Luke earned a PhD in chemistry at the University of Iowa before going on to explore all natural alternatives to petroleum-derived plastics as an assistant research professor at the U.S. Naval Academy. His vision to develop bio-neutral, high-performance materials from renewable natural nutrient inputs has become the foundation for NFW's ecosystem of patented, paradigm-shifting material technologies. In an industry awash with incremental solutions, Luke is leading NFW to drive a moonshot systems-level shift away from petroleum-derived products and toxic chemistries. Luke is an Unreasonable Group Fellow, Forbes Council member, and World Economic Forum technology pioneer. And I also noticed, Luke, that you had won the Intellectual Property Owners Education Foundation's Inventor of the Year Award for 2022. So congratulations on that.
Thank you. And to Aaron Amstutz, our CTO as well, who's a huge part of that equation, along with myself. But yeah, thank you.
Congratulations. So in doing a little bit of research to prepare for this, Luke, I read that you have said that the seeds of discovery for the company were planted in academia. Can you tell us about those seeds and how they've ultimately sprouted into becoming the company that you have today?
Yep. So well-formed questions, knowing that what we build materials out of are things that come from seeds and from the earth. So when I joined the Naval Academy, there was a program that we were working from, sponsored by actually the Air Force, that says that the program was looking at extremophiles and natural systems. So there are, we kind of in our everyday life, you interact with different kinds of materials, and yet life is far from everyday and ordinary. There's life that is active near volcanic vents at the bottom of the ocean. There is materials that we take for granted that we see around us every day that humans don't know how to really fully replicate when you're looking at spiders and things like that. And so the program I was part of was looking into, like, how is it that nature puts materials together? How do those materials work? If you can understand how they are put together, how they do work, then maybe you can replicate those kinds of properties and things that you see. So that's where it started. And then, I had the good fortune and privilege of growing up on a farm. And so I didn't take it for granted that these materials are kind of extraordinary, even if they're in our everyday lives. And I started thinking about what I was learning about these natural materials, how those natural materials actually could outperform plastics, how they could outperform a lot of the synthetic sort of systems and infrastructure that we have in the world. And if you could solve the right problems, how therefore nature could actually be the basis of not only what we need to eat, but it could be the basis for what we wear, what we put around us in our built environment in a much more active way than it is today with synthetics. So that's where we got our start, was fundamental learning about how natural systems work and trying to extend that knowledge into new areas.
Yeah, it's interesting. You know, I'm sitting here interviewing you, Luke, from Iowa State University. My career has taken me from having started companies to at least part of my time spent in academia, but you've decided to move something that was in the laboratory to something out into the world. But gosh, it seems to me like there's a big difference between the laboratory and creating a commercializable product, very well a company that can scale in a production system that I would have to guess is pretty complex. So, you know, as you think about that, what so far at least have been some of the significant actions that you've taken in moving from lab to building a business?
So when you're in an academic environment, you have lots of choices, but here's a choice that sometimes a lot of people who are in academic environments don't realize that they have. When you go to do an experiment, or when you even approach, like, what should I be experimenting on? Then there's a fundamental choice about, do I want to just learn something new, or do I want to solve a problem? So it's that's subtle, but maybe to some, but it's actually, it's profoundly different in how you do your approach. And I've always kind of made decisions about, as I was learning chemistry and technology, and I love chemistry, I love physics, I love math, I love lots of things. I love music and other things too. I've always been very interested in applied, what you learn and how you can apply it. I like learning about fundamental things too, but I'm always like curious about, like, if I learn this fundamental thing, like what's it good for? All right. So there's a lot of chemistry that people do where it really is learning about, like, how to make carbon-carbon bonds in new ways, how to discover mechanisms of some esoteric, brand of E. coli or something. How does it work, and how does that particular organism live in a slightly different way than a cousin or something like that? And a lot of that learning isn't necessarily directed at its start at trying to do something right away. Humans need fundamental knowledge. When people have said, if I see further, it's because I stand on the shoulders of giants, then there's a lot of these giants underneath of modern technology where people were just learning things, and it wasn't always apparent, like, that this pure math turned into being a better way to solve differential equations for, landing people on the moon or something like that. Okay. I made the willful choice that the kind of chemistry that I was going to pursue was going to solve a problem I was interested in. And that problem was actually an economic problem. And the economic problem that and I'll say, if the technology, if the laws of physics and chemistry and the reality of what plants are growing around us and things of scalable agriculture, if in fact the universe that we live in didn't allow NFW's technologies to work as well as they do, then I would still be in the chemistry lab trying. So I set out on a very kind of like specific kind of journey. I was going to work on chemistries that would allow people to displace plastics and petrochemicals using nature, natural systems, natural nutrients. And fortunately, for me, but I'll say fortunately for everybody, the state of technology in the world today, the state of the universe in terms of how plants grow, is such that you don't need petrochemicals and plastics. In fact, we should move away from them very rapidly now because NFW exists, and there's a new form of circular economy that can be run that's going to be decarbonizing the world, detoxifying the world, and making the world more efficient so more people can benefit from these technologies all at the same time because it's good business. So I sort of like started in the lab with a particular approach, only was interested in the kinds of technologies that might be a potential solution. Then very fortunately, because the laws of the universe and human history is as it is, the solution emerged, and then I could become an entrepreneur. So that's kind of the progression.
So maybe this is what happens when you put a farm boy in a PhD chemistry program.
It is with
Research.
and then you add these laws of the universe that we operate under, and it becomes inevitable.
You know, I've compared notes with other professors at other universities that teach entrepreneurship classes, and so we compare ideas coming from our students, and most of the students that sit in my class, since I am in the College of Agriculture and Life Sciences, tend to be people who've come from farms or agricultural businesses. And I think they do a pretty good job compared to young people at recognizing problems because they've got their hands in them. You know, they're involved in production agriculture, or whatever the case may be. Do you think part of you kind of focusing in on a really big problem and trying to come up with solutions to that also relates back to that experience of growing up on a farm?
100% it does. You know, I'm old enough that I remember my grandfather and father running the P&L on notebook paper. Now we have spreadsheets for that, right? But back in the late 80s, not every farmhouse had a computer in it yet. So, all right, I'll say anyone who has the privilege of growing up on a farm gets to grow up as part of an entrepreneurial experience. Farmers are entrepreneurs, or that activity is inherently entrepreneurial, typically. So that and then very, like you say, the very practical things of, hey, if you can't grow an acre of corn, or if you can't sell what an acre of corn can produce for more than it takes to grow it, then you're upside down, and how do you have a business here? So I took those experiences and those kind of practical learnings straight to the chemistry lab. And then when I started thinking about what chemistry I'd be pursuing, I'll say a lot of chemists, again, when you're just doing fundamental knowledge, you don't worry about things like unit economics. When you have a problem you're trying to solve, and in my case, what I recognized very early on was this was not just a chemistry or a manufacturing problem to solve. This is an economic problem to solve. Then it puts another filter on what you're trying to do and what approaches you're willing to take. And so that economic filter, especially unit economics, is a large part of how it is that we got, to this conversation today.
Yeah, I mean, we've done and tried a lot of things that would be called bio-based, which, okay, whether it's biodegradable, derived from more sustainable, but yeah, too many of the early efforts, at least that I have seen, did not check the box that you have talked about, and that's unit economics. Oftentimes, not even close. And so they did not really stand much of a chance in emerging into the world. So did you really have your eye on that, sort of the feasibility of it from an economic perspective from the very beginning?
Exactly. When you understand why plastics are successful, one of the part of the story that's an economic part of the story is that a huge amount of the infrastructure required to make plastic didn't have to get paid for by the plastic industry. It was paid for by the fuel industry. So if you're going to come to market with some new alternative form of material, like some bioplastic, then if that bioplastic needs to be produced on a new kind of infrastructure, then you're left with the economic problem of who's going to pay for it up front, because you can't produce the plastic without having it up front. But the infrastructure tends to be very expensive for a lot of bioplastics. And there's not a fuel industry and the gross margin dollars of JP8 jet fuel and diesel and gasoline to pay for that. There's not that synergy. So that meant that I wasn't interested really in doing a lot of discovery of how you might have to genetically engineer something in order to get it to work right. I didn't see much of a pathway forward there for a lot of the applications that NFW is interested in, because, well, simply put, even if you come up with the right genome in yeast or something like that to produce some material, then you're still left with the whole rest of the manufacturing equation. You're still left with the space-time yield of a fermentation vat, and it's fundamentally limiting. Like when you look at like fermenting things, you have to keep the thing that's doing the fermenting alive for a certain amount of time. Mm-hmm. And that ends up being a huge infrastructure cost and energy cost that a lot of people, when they're just focusing in on thinking that it's like programming a computer, they're forgetting that, there's this real infrastructure thing on the other side that you have to contend with. So I was interested in, okay, when you think about what materials NFW's using now to make camper shoes possible, to make, Ralph Lauren polos and my shirt, and then you look into the world and say, well, there's already these huge scale commodity nutrients that are available in the world. And what would be the simple, very cost-effective, highly efficient way to convert nutrients into leather alternatives, foams, molded composites, fabrics that perform? If you can do that, then not only do you have all that efficiency, but efficiency also means things like low carbon footprint. Efficiency, using nutrients already by default means probably not going to have toxic stuff, especially if you're intentional not to put the toxic stuff and mix that with nutrients and then pretend nutrients plus toxic stuff equals good, when it's like nutrients plus nutrients is what equals good, healthy things. So that's that kind of mindset is on one hand constraining. On the other hand, it's the constraints you need to get to the right kind of answer that can work.
Yeah, so use photosynthesis to create a product.
Use photosynthesis. Maybe I should have just said that instead of the long-winded previous answer. But photosynthesis is the most productive, system humans know of, and it's all driven by solar energy. So what? And it's, by the way, and what are plants doing? They're sequestering carbon emissions, and part of the energy of the solar energy is going into building the plant that you see above ground, but then a significant amount of the energy is part of building an ecosystem below ground that can actually sink carbon in a durable way in the soil. So you can't, and that technology is deployed on every continent. And so what you can drive for miles and miles in the Midwest, right? You can go out of Ames. You can head to the Northwest where my family farm, where I grew up is, but you can also head north or south, and you can drive for hours and hours and see nothing but green. And if you put all of that green stuff on a scale and considered how much output that is, all solar powered from the earth, and you compare that to what people might otherwise get from a reactor, what you find out is, yeah, nature wins not just by a little bit, it wins by a lot.
Yeah, somebody from one of our researchers here at Iowa State, and I'm not even going to remember the reference, but they showed this map of photosynthetic activity from like a satellite and globally, and it was like a July. And so the Midwest was the most intense photosynthetic activity of any place in the globe, rainforest or otherwise.
You can literally watch carbon dioxide concentration in the atmosphere drop when these plants turn on. It's absolutely phenomenal. It's something that we got to do better, like teaching in school, because the more people that understand this, the practicality of that, understand that when you have hard economic problems to solve, then there are very few answers that are economically relevant, not just technologically relevant, to doing things like dealing with some of the global issues that humanity has in front of it for the next few decades.
I might turn for just a moment, Luke, to asking you a little bit about your business as an organization and culture. So I think when I first met you, it was you and a handful of others that would be your team. Today, I think you're at something closer to 200. So your team has grown considerably, a little bit more. And so I read a quote from you that you said, "My pursuit is to build a purpose-driven organization." Could you, I think you've touched on it a little bit already, but could you describe the purpose of the organization as you've created it? And how do you think about culture as you've taken the company
Yep.
from inception to where you are today?
Yep. So let's go back to when it was just me in a chemistry lab, or well, working as a collaborator within a chemistry lab. But and what I said earlier about purpose before you even design the experiment. I wanted to solve a hard problem. So one of the cultural elements of NFW is we're not afraid of hard problems. In fact, that's what we're built to do, is solve hard problems, hard multidiscipline problems that are economic, technological, and societal all at the same time. And if you want to state at the highest level, what I hope to accomplish with NFW and what I hope our company collaboratively does is we enable more people on the planet to live better with less conflict. So when you think about today, where you see conflict, there's a lot of conflict both today and maybe I wasn't as good as a history student as I was a chemistry and math student or something. But one thing I learned in history class was when you have scarcity and fear, you have huge potential for conflict and problems. And so you see that around the world. So agriculture is abundant. Now, at this point in human history, we produce so many calories, humans can't possibly eat them all. So we feed them to cars, which, we can have a debate about how much of that we should do. But the point is, if there's a really efficient way to convert the byproducts, co-products of what you can grow and eat and convert that directly and efficiently into what you wear, there's no, and while sequestering carbon out of the atmosphere using solar energy, then won't that be the best solution? So from a purpose perspective, NFW, we're running technologies, we're developing technologies, but the team is built to solve hard problems. We're built to solve hard problems in complex environments and collaboratively with a lot of different kinds of partners. And then we're very mission oriented in the sense that everyone that seems to be joining the company these days really appreciates the fact that, people generally speaking try to be good people at home, right? So if you're trying to be a good person on the weekends and when you wake up and get in the car to go to work, and then you want to be a good person when you go home from work, and isn't it nice to also devote your professional career towards something that can be genuinely good and be beneficial so that you can be holistically through your whole life anyway, do things that are kind of in sync. So I think our company technologically, how we approach problem solving lends then towards being attracted to a lot of really highly skilled, talented, brilliant people who want to show up at work in the same way that they try to show up at home, which is to be genuinely good, trying to solve problems that are challenging but do it in the right way.
Yeah, it's been 13 years ago now, but when I interviewed at Iowa State University to run the entrepreneurship program that I today do, after having started a couple of companies of my own, one of the professors in my seminar said, our students here all get jobs and they get paid quite well. Why do we need an entrepreneurship program? And the question was fine. And I said, I've tried to hire students from Iowa State University and had a difficult time competing against larger companies in doing so. So I agree. There's a pretty good market for their skills. But I said what I've also have discovered is that 3 to 5 years after those students get those good jobs, half of them, my estimate at least, are going to be saying, is this all there is? And it's, I think, what you're getting at, Luke, that search for meaningful impact in what they do. So
That's right.
When you are so forward with solving hard problems, a really hard problem, and that meaningfulness, it's probably a chicken and an egg question, but do the people you attract to your team kind of grow into that mission, or do you think it attracts the sort of people who are mission and meaning oriented in the first place?
Yeah, it's both, certainly. I mean, there are very real examples I could give of where we were recruiting and have been recruiting top talent and extracting top talent from other places. And one of the primary ways that we're successful is look what we're doing. Or in some cases, I'll just say, when I say extract, usually the way the connection is made is people on LinkedIn, for example, will read some of the things that I write and they'll say, how can I be part, like, sounds like you really care about the problem here. Well, let's talk some more. And then after you talk some more, then they turns out they're willing to join NFW because they think it more missionally aligns with what they want to do than what they might currently be doing. The other thing that you mentioned is also true, which is we've got a lot of really wonderful, dependable people that are in Peoria, Illinois, that are very glad, I think, to have found a job. Maybe they didn't know exactly what NFW was, what they were going to be doing in the Southwest Jefferson plant when they first applied. But now that they see banners hanging from the rafters of when they do their work and they do it well, that it turns into this kind of stuff. That's pretty exciting. And then it makes, and then they learn more. And they're, now what's cool is people who are taking care of business day to day with operations, they can see the fruits of their labor. They can see it in market, and they can connect it with the dots of how the company is working, and why so many brands are reaching out to us is because they're all sort of synergizing about, if we can do it more efficient, if we can do it in a way that decarbonizes and detoxifies supply chain, then that's something to talk about, and it makes you feel good while you're doing it.
Yeah, and so two of your technologies, Mirum and Claris, became commercially available this year, if I've researched that correctly.
Yeah, so at this point we have 4 ingredient branded families of materials. So it's important to note, I'll say that when you go to our website, there is like some people are always curious about the technology and what's going on. I'll say there's a lot of technology underneath, but sort of if you think about, again, using the dirt analogy, think of our intellectual property and all of the different technologies underneath. There's many, and so it's like soil has many components. Our technology portfolio has many components to it. What emerges are the ingredient branded family. So Claris is a performance line of fabrics that can be, we figured out how to basically mold and shape natural fibers. And when you can mold and shape them, then it gives them the geometries and the morphologies that only synthetics really could have before, and allows you to then do things like recycle cotton, make many different kinds of natural fibers more durable than they could ever be. So that's Claris. That gets you to, breathable, moisture wicking t-shirts, polo shirts made efficiently from again, materials that nature knows how to recycle.
But with the performance characteristics that have favored those petroleum-based.
Then Mirum is a leather alternative, or you could just say it's a complement really to leather. It's an engineered material that can do many of the things that leather, but also polyurethanes and different kinds of synthetic composites that people make. It can do those things, only it can do those things again in a way that you can return it to earth safely. It's recyclable. You can make it from a lot of different waste inputs that are very low cost. And so it ends up letting you then do what you want to do, but at price points and with an overall sustainability envelope that you couldn't do any other way. We also have Pliant and Tunera. So Pliant is a molded composite material that we're starting with shoe soles and outsoles. And Tunera is a foam product. So if you think about what you need to make a shoe, you not only want the upper of the shoe and the laces, but you also need the part that's going to be hitting the pavement, and you want to cushion your heel from that hard pavement. And so if you stop and think now, I've just described families of ingredient branded materials that when you put them all together, you can do something even more, which is you can make a whole nutrient shoe or bag or couch, or the list goes on. So that's circular economy. So when tying back to the intro at the start, the whole idea of solving a hard problem was not just to come up with individual point solutions that are natural versus synthetic, but to actually have a new emergent low carbon detoxifying circular economy. That's a big big problem and solution set. But here we are, because nature runs a circular economy, and because I grew up on a farm, I figured that the best solution would be try to figure out how to fit human circular economy a lot more like what nature and where we kind of came from in the first place, how that all works.
Well, you think of even the old time farms, and you, yeah, use everything. And so you raise livestock and you use
That's right.
the manure as fertilizer, and
It's all nutrients.
you consume some of the food and
Yeah.
sell some of it in town. And anyway, it's coming back, except making the circle much bigger from beyond the farm to, well,
That's right.
out into the world.
That's right. Nature doesn't use the term or doesn't worry about upcycling and downcycling. You only have to worry about upcycling and downcycling when you make something toxic or that's scarce.
Mm-hmm.
So this completely, the best part of circular economy, especially the natural one, is it completely opens up abundance in a way that you can't do it any other way. That takes care of a scarcity problem. And then also nutrient cycles in nature, nutrients sort of well up and they go back down, and that's less of a circle than you might think. It's more of just a flow, an ebb and flow.
Mm-hmm.
So we're trying to fit and match that pattern.
So you're doing business with brands that I think almost everyone would recognize, just to name a few: BMW, Ralph Lauren, Allbirds, Patagonia, many others. You showed us some of the products on this.
Yeah.
What's it like to work with brands like that? And again, I come from an agriculture and food perspective, but my perception, at least, of the value chains that you're participating in is that they're multi-layered and pretty complex.
Yeah. It's not all roses every single day, I'll tell you that. It's super energizing to do it. Again, it's one of these hard problems. It's like, so if you're a big brand, first of all, we'll note whether you're in cars, consumer electronics, shoes, apparel, accessories, more and more, every brand in the world that delivers material goods is recognizing they have this kind of hole or this problem to solve in their own brand. And that's like probably what they're doing is using a lot of carbon, putting a lot of, using the atmosphere as a dumping ground. There's also the landfill dumping ground. There's toxification that's happening in ecosystems. And, right now we have a world where rain all over the planet is contaminated with a liver cancer causing type of chemistry synthetic plastic, basically, that has gone global because of how the fracking industry, certain materials industries that use coatings and things have worked. Okay. So brands are recognizing they need to do supply chain differently. Mm-hmm. Along comes NFW, and the first 5 years of the company, we did nothing but we got beat up by brands. I mean, we still get beat up. We still take our knocks, but really the first 5 years was really difficult because what we were doing was eliminating all technical risk to what we're now scaling. So you get a lot of feedback from brands, from the product managers and brands, from the sustainability sort of managers in the brands, from the executive side of brands on what they want. And they, depending on their perspective, they want different things, but it all sums up to, well, they all want circular economy. They all want price to performance ratios that win markets and let them differentiate their products. They all want information about where the materials come from and where they go to. So there's these patterns that emerge when you understand how to integrate the signal the right way. And so what we did was we got beat up a lot by a lot of people, not just brands, by the way, but then you get introduced right away to the supply chain that serves the brands, and they beat you up even harder.
For sure, objections come from potential competitors.
Yeah, that's right. And so you got to integrate all of that, and then come up with your own unique value that you're going to add. In the case of NFW, it turns out the unique value is we're doing something categorically new in this world. And there's a bunch of people in supply chain and in brands that when they actually get to experience, what this is, they're like, then there's no, once they experience what we're doing, there's no going back to the other stuff. So that's the exciting point that we're at right now. When you list those names, and we could list more, right? Wolverine Worldwide, and Merrill is a brand in Wolverine, for example, and you can talk about Deckers and New Balance, and okay, the list goes on in footwear, but then we can, say more things about some of these other categories. It's super exciting, and it's super exciting that what we were able to do now is deliver. If you imagine if a material can work for Ralph Lauren and Patagonia, then you can imagine who else it works for. Mm-hmm. And what's really great about brands like Ralph Lauren and Patagonia is they're willing to teach us what we need to do to be successful. And then they weren't so, they're very, very generous in how they think about that they don't pretend that they're going to sell all of the world's clothing. So it really is a collaborative environment in the end, where if you can make Ralph Lauren and Patagonia happy, then you can also make lots of other brands happy, and they're very happy to support because they know that they already have their niche places and markets that they're going after. And it's not that there's not competition, there's competition, of course, but it's a very collaborative, healthy thing that can emerge when everyone rallies behind a common mission about what we're trying to do.
So as you go to some of these brands, they have some buying power, and I've seen entrepreneurs who create something that's truly unique, and some of the first conversations that will happen as they prove something to a large buyer is, well, we like it, we'll do more. Let's talk about an exclusive arrangement. Mm-hmm. Is any of that rings? I was going to ask if that rings true for you and how you've navigated that.
The way you navigate that is you say, look, sometimes there's just realities to companies like ours, which is we can't serve everybody all at the same time anyway. So, sometimes you can say to folks, look, you can ask for exclusivity, but effectively, if you do this agreement with us, effectively you've got it, what you want. So do you really have to tie us up? The other thing is you can note is, if you ask for exclusivity, then it's okay, but what are you going to provide in return? Mm-hmm. And if you're asking that question, then maybe I'd go to your competitor and say, you can give me a shiny nickel for this, but maybe someone else has got a shiny silver dollar for the same thing. So, there's that. And then the other thing is, usually what makes sense is something in the middle. There usually is a limited time, limited geography, or limited market sort of compromise that you can come to that doesn't bind us up working with everyone else, but does give, the entity that's providing the right kind of resources, the right level of business assurance on a go forward, that they can get their return on investment that they're looking for out of that input to help us get going in the first place.
It's a totally different industry, but an entrepreneur told me a story of he was ramping up a unique ingredient that was new to a space and trying to get his first big customer, and ultimately got them. But and so the customer came back and said, I will buy what you asked me to buy, and I'll do it at a price above what you asked. And so the guy said, well, why? And he said, I'm not asking for an exclusive. I'm not asking for anything other than, as you ramp up your production capacity, would you call me first and let me know and give me a chance? Yep. I thought that was such a constructive way to engage a company that's trying to scale.
Kevin, it's a great anecdote because, in the end, business is a human set of interactions. So humans building relationship with other humans is that story is a really beautiful one too, of people building relationship. Clearly those two entities, they came off better from that deal, and then they decided that anyway, missionally, they didn't have to write everything down in ways that bound each other up for forever. They could continue a relationship and grow together.
So you've talked, Luke, about some of the objections when you're putting something new into the world, potentially displacing other suppliers, doing things differently. So that's sort of one level of risk. But, as you think about the risk that you've had to overcome and some of your strategies for mitigating some of those risks, what are some of the big categories for you of risk?
So I mentioned we spent the early years of the company eliminating technical risk
Mhm.
and building the intellectual property that allows us to, anyway, operate on a go forward without. There's a lot of things in this world where it takes a lot of time and energy to discover what the answer is.
Mhm.
Once you know the answer, it's not hard to go backward.
Yeah.
So, we have another discussion sometime about intellectual property law and all that. And NFW uses, I'll say, all the tools in the toolkit very holistically. That's why we ingredient brand the materials. That's why we have supply chain agreements we do, et cetera. All right, but that's all different kinds and buckets and colors and flavors of technical risk. So we're working on eliminating that. At the same time that you're working on eliminating your technical risk, you can work on eliminating your market risk by asking your end customer. What you never want to do is assume that the customer is always going to stay in one place and that you 100% know their pain points. You always want to be checking while you're building technology if it actually meets what people want. And then you want to look at all of that and say, and by the way, the sum total of elimination of technical risk and elimination of market risk, if you're really crafty, you can have, you can do things like Tesla did. And I'll say NFW is approaching its Tesla moment here, where we understand patterns of behaviors by having spent a lot of time asking questions and thinking about how to deliver solutions and answers to questions. We now know things about patterns of behaviors that other people don't. And that allows you to build brand in a completely asymmetric way that we know where we're going right now. Other people don't even know where we're going, but we know where to aim an arrow at that other people wouldn't even know what to be shooting at this point in time. So that's a powerful thing. All right. And then where we're at right now is we're scaling and there's execution risk. So execution risk is first of all, some people try to execute too soon, and you can get really, really good at, like doing this, but that doesn't win. That you might be the best in the world at doing this, but it might not be good at, scoring a touchdown and win the football game. So you got to understand, like, what activity am I doing here that is useful and beneficial? And now, okay, once you know what that is, how do I do that the most efficiently inside my company? And then also working with supply chain and with the customers and the customer of my customer and all these kinds of things. So right now, I would say we're firmly in this moment of order of magnitude thinking says work on your execution risk of various sorts, supply chain, certain kinds of things with brand customers and products and applications. And that's really fun because now you're turning on a really, really healthy, hellaciously large in the future business. So yeah, that's when all of the sort of proverbial chickens come home to roost.
So you mentioned Tesla, and on another podcast, Elon Musk, somebody was asking him about risk and problems. And so you're on this podcast before he is, but I heard this on another podcast, but he said, prototypes are relatively easy, but scaling manufacturing is a wicked hard problem. That's what he identified as the hardest thing. And so that's the execution risk thing that I think you're living right now.
Yeah, we have a concept in NFW. There's a lot, you can read a lot of entrepreneurial books about minimum viable product. And I think what Mr. Musk is accurately pointing out there is some people misconstrue a prototype with product market fit. And then I'll say even further than product market fit is what I would call minimum viable business. Yeah. That's even beyond. It's one thing to have product market fit. It's another thing to have minimum viable, and then viable business. And that's the kind of work you do when you're scaling something that can work, but you got to do it the right way. So, NFW, one of the early things we did is we worked with NSF I-Core process or program. That was a really good program. You learn a lot about how to do customer discovery and build technologies that solve problems as opposed to thinking that your technological hammer drives every nail in the world, in a world where there's also screws and other kinds of things, right? So there's a lot of truth to that. And I'll say that the other risk is never being satisfied that you have 100% knowledge of something. You always got to be digging for it's what you don't know sometimes that is the thing that, anyway, you got to be looking for.
Yeah, I do think you always have to assume you're missing something and you don't know what it is. So the search continues. Yeah, so I mentioned to you earlier, Luke, that my diving into the textile industry was to profile an historic American entrepreneur named Francis Cabot Lowell, who had created a company back in 1814 called Boston Manufacturing Company, the first integrated cotton textile manufacturer. And as I read about what he did, did a number of things that were pioneering, creating a large business. He was in the industry really that was at the forefront of what's now called the Industrial Revolution, but he ended up being crazy smart at math and figured out the mathematics of weaving and designed a better weaving machine, better power loom. So anyways, I've, done more research on textiles. Has played such a significant role in the history of technology. And I think it's just really cool to see how NFW really is at the next step. As you think about kind of technology and how it progresses in the space that you're in, how do you think about that? And you talk about seeing where the company's going, but it seems like a sort of a inflection point, if you will, in an industry that certainly has been around for a while because everybody wants clothes, and materials, but it's a different point.
Yep. That's a great riff off of what I was trying to say earlier with new kinds of behaviors. There are certain consumer behaviors that are, when you ask the right questions and you integrate, you start to see patterns emerging. And then when you combine that with deep supply chain knowledge, then it tells you very particularly what kinds of problems are the problems worth solving. And remember, I'm a chemist. Chemistry is the central, people call it the central science. It literally is in between, I'm not going to get into the whole thing, but it like everything kind of in the end boils down to chemistry of one sort or another. And yet when you go one layer out of the onion from chemistry, you're in manufacturing. You go a layer out from that, you're in logistics. And so one of the things that's really cool about, and this is kind of, I'm trying to explain too, why history repeats itself in the way that you kind of like laid out the pretext, is the reason why history repeats itself is, number one, is there are always certain kinds of consistencies. Like people want to wear clothes. Seems like a pretty consistent thing. I don't think there's a lot of venture capital investors out there worried about, we're headed towards a moment no one's going to wear clothes anymore because they're it's unsustainable to wear clothes. We're not going to, people are going to wear clothes. So there's some certain kinds of things that are consistent, but then what emerges and what's successful are those things that you recognize certain kinds of behavior and you match that with deep kind of technical insight and you put that together. That's how you get to things like, iPads and iPhones and all kinds of things, right? I mean, that's how we get to that kind of stuff, is people putting those things together. So NFW sees this moment where, okay, we've got the most productive system humanity yet knows about called plants. They're not going anywhere. We've got these inefficiencies of that we're not using as much of the commodity stuff that's byproducts and co-products of food anyway. You got the confluence of precision agriculture is happening, and the ability for really precision agriculture is the only really credible economic solution to durable carbon sequestration and storage in the planet. Someday the regulators will wake up and realize that that's true. And then, and now we have this ability to like take all of that kind of stuff that's only going to be more important as we go on forward in history and apply that to everyone wants clothes, shoes, furniture. And in fact, not just everybody, there's a bunch of people in this world that haven't yet got to consume that stuff. there's a lot of people in the world saying, well, Americans should consume a lot less, and there's a good critique and thing to talk about there. But there's 400 million Americans. There's still 7.2 or something billion other people on the planet, and many of which want to join the party.
They
So if you're
aspire
going to
to
let people
exactly
join,
that. They want to become a global consumer as well.
if you're going to let more people live better with less conflict, then you got to do what NFW is doing.
Yeah. So you mentioned Peoria, and as I was preparing for this, I had to Google it, but I remembered this old phrase, "Will it play in Peoria?" which in a more modern sense was used in politics, but in doing some research, dates to vaudeville, and if it'll play in Peoria, it'll play anywhere. It's sort of quintessential middle America. So as you think about building this company in middle America and Peoria, how do you think about Peoria and about the Midwest as a place to build a great business?
We've got great people. We've got great plants. We've got a lot of healthy soil, a lot of sunlight. We're logistically in the middle of markets that you say most people are on the coasts, but there's a reason why windmill farms are appearing in the Midwest, why Amazon fulfillment and warehousing is in the Midwest. You think about how do you get things to people quickly in a day. And you understand why Amazon and also like not just things, but also even like information when your data farms are centrally located. You start thinking
server farms are in the Midwest.
Yeah, and because there's wind energy, there's renewable energy here, and there's I think most people get their internet fast enough where they're not worried about latency issues quite as much as we used to. I remember the dial-up days, but anyway, you get the point. Like, so I think the other thing that was serendipity for me was how capital efficiently you can get space and highly talented people. And when you're in Peoria, Illinois, you've got Bradley University that's graduating highly trained, motivated, young, hungry engineering talent, and we've benefited from that. And so you get lots of opportunities to, in a very efficient way, execute.
Well, I'll wrap up with a question, and so there will be innovators, entrepreneurs, aspiring entrepreneurs that will take many great lessons from what you've given us today, Luke. But if you could call out anybody for the help that they've provided you along the way, who would that be, and what did they help you with?
Okay, this could take a while. I'll start with my wife. I am able to perform in certain ways only because I have support. Not just support, I have a partner, collaborator, lots and lots of things. I could go back further and say my parents, my grandparents, now my parents-in-law too. So I have very, very strong family and friends network. I could mention a guy named Michael Greller, Ben Lacey, a whole bunch of people in my background that kind of like created the potential or the inevitability for me to become who I am. But then, more specifically to NFW, there's people like Steve Zika, Ken Zika. So the Zika family in Peoria, Illinois, at some point there needs to be bronze statues made of these people, because when I was the pitch of NFW, we were talking a little bit before the recording here that you can remember NFW's pitch way back to like 2017 or whatever it was. And Steve Zika and Ken Zika heard the NFW pitch even before that. I'll say the pitch has never changed. The real amount of proof of de-risking and execution has changed dramatically, especially now. Things are dramatically changed. They were willing to, even when I had all of the risk and they hardly knew me, they were willing to trust me enough and to give me significant capital to try. That is an amazing thing. That is really an amazing thing when you stop and think about it. Like in Peoria, Illinois, some guy talking about changing the globe with circular economy kind of stuff. You know, doing that in a way where, and by the way, the pathway wasn't clear that I was going to be able to know how to raise a lot of money or be a good, it's not like I have a pedigree of being a good CEO of anything. So they gave me the chance to try. That's an amazing thing. I'll say there's other investors around Peoria, Illinois, and in the Midwest that also, like, because the Zika family helped validate me, then they also, put their resources and got behind the mission and the idea. So, okay. And then now we're further on, and there's a whole nother crop of people, now around the globe that are putting their resources behind this company. I could mention people like Andrew Forrest and Tatarang, and like there are some other unbelievable entrepreneurs in this world that it wasn't my idea to come up with climate tech company or something like that, right? It's like there's other people in this world that are doing amazing things that are inspiring to the rest of us that are trying to anyway build the dream in the way we're trying to build it. So I could talk a long time about that, and then I'll just apologize in advance for everyone who is friend, family, NFW employees, etc., that have done amazing things. And I'll say it's certainly my experience. It's not me really. It's the we, and it's the we coming around an idea. And I'm very privileged to live at the time I did, be exposed to the kinds of things I was. And then I'll say this idea was inevitable, and I'm just fortunate to get to be a part of it. Thanks to everyone else who also is doing it with me.
Well, thank you for everything today. And I mean, just congratulations on the great progress you've been able to make with the company. I mean, I just think it sets a tremendous template for doing things differently. And as an agriculturalist, I couldn't be more excited about turning loose, agriculture to, help solve major problems.
It's again, it's when you look at the combined total of economics and logistics and everything, and you're left with, boy, there's not many things that are more scalable than sunlight and green plants and healthy soil.
With that, thank you, Luke.
Thank you.